In 2019, Capital One suffered a major data breach. As part of this, personal information of more than 100 million customers was stolen. The person behind this hack was Paige Thompson. Capital One was found to be negligent for leaving this type of sensitive financial data open to the public. They had to pay a fine of 80 million US dollars. In addition to that, they also had to settle many other lawsuits as well, for which they paid around $190 million. So in this video, we will try to understand the technical details of this particular incident, and we will see the related best practices which should be ideally followed in your cloud environment. Generally, it is difficult to realize that why should we follow a particular best practice unless until we see an example that what could go wrong. You will see in this particular video that how a small indiscipline can actually lead to real big damage. Okay, so what are our objectives? We'll go ahead and understand that what went wrong with Capital One, right? They are a big bank. Of course, they have a really good cloud practice, but still some best practices were not followed at that time. So we'll try and understand that. We'll see the steps which were probably followed or which were followed during that particular hack. And then we'll see that what new measures got introduced after that, and how can we go ahead and actually use those measures. And some of those are kind of non-negotiable, right? And we'll not just talk about it over slides. We will also see a practical demo around some of these best practices. So if you're ready, let's get started. So let us first look at the setup which was there in 2019 for, at Capital One. And this is for this particular incident I'm talking about. Here is a simple diagram which actually represents the scenario at that time. You can see that within AWS in one of the regions, there was a VPC, and primarily the component which we are concerned here is this EC2 instance. So they had an EC2 instance on which a WAF, web application firewall, was configured. So there was a web application firewall called Mod Security, which was an open source popular WAF at that time. So the team had configured Mod Security WAF on this particular EC2 instance, right? And because it is WAF, you can expect that this particular EC2 instance was kept in the public subnet, right? Because it is WAF, so of course it would be accepting traffic from internet. That's why this particular EC2 instance is there in the public subnet. So our hacker here, Paige, what they did was they were able to hit this particular EC2 instance, right? And this particular EC2 instance, or I should say the WAF, was not properly configured, because of which Paige was able to actually do an SSRF attack, which is server-side request forgery attack, on this particular thing. Essentially, in simple terms, what happened was that Paige was able to figure out this misconfiguration, and hence Paige was able to run certain commands on this particular EC2 instance. And like to this EC2 instance, it would look like that the commands are being run by that EC2 instance itself, right? That it is originating at that instance level, but that was not the case. It was actually pushed by Paige, or by our hacker, let's say, right? You know that on an EC2 instance, you can go ahead and hit your instance metadata service, your 169.254 URL. So you can go ahead and hit that URL, and if you hit that URL, you get all the details about that particular instance, right? So now the way this instance metadata service is designed is that you can only hit it from a particular EC2 instance, and the EC2 instance from where you hit it, you get the details about that particular instance. So if I go ahead and hit that particular URL from this EC2 instance, I will be getting the details of this EC2 instance only, right? Not of anything else. Now, the problem there is that when our hacker actually executed or went ahead and actually hit that particular URL, hacker found out that there is an IAM role associated with this EC2 instance, right? I will show you that how you can actually get all that information. Maybe some of you know it already, but we'll see it in the demo. So our hacker figured out that there is an IAM role attached to this EC2 instance. Great. So what they did was they actually went ahead and extracted the credentials for this IAM role, right? What does that mean? Now, IAM roles do not have a long-term credential, right? You know that, like your IAM user will have an access key ID and secret access key, which is long-term, right? Which means, it doesn't expire. You can go ahead and rotate it, but it doesn't expire on its own. But in case of IAM role, you don't have a long-term credential, which means when you actually go ahead and give an IAM role to your EC2 instance, what happens is at the backend, an access key ID and secret access key gets generated. But in addition to that, a session token also gets generated. And that session token has a certain validity, right? So AWS internally keeps rotating these credentials, and they are not long term, right? Okay, so I've written down the different steps which were executed, as part of this hack. Hacker was able to do this SSRF attack on the EC2 instance because the WAF on this particular EC2 instance was misconfigured, right? And post that, as part of that attack, they were able to go ahead and actually execute commands, and they were able to hit the instance metadata service, which and as part of that instance metadata service, they were able to figure out that there is an IAM role allocated to this EC2 instance. I can show you that how easy it is to actually find that out. So once they figured that out, they also went ahead and they were able to extract the temporary credentials for that IAM role. So once they had the credentials, they went ahead and configured these credentials on their own device, which is now totally outside of Capital One's network. And once they configured these credentials, they executed AWS S3ls, which is a simple command, and it listed down all the S3 buckets in that particular account. And then they looked into, in one of the buckets, and they just ran a sync command. Now, say AWS S3 sync is a really powerful command, right? It can actually sync all your data from a particular folder from your machine to an S3 bucket or vice versa. So which means it doesn't matter how many recursive folders are there or files are there in a particular bucket, they just dumped it all to their device, and it was around 30 GB of data, right? So that's what happened. Now think about this whole flow. There were many things which were wrong here. So first thing, if you see, it all starts with the first mistake which our hacker figured out, which was that the WAF was configured in an incorrect way, or it was misconfigured, which allowed our hacker to get inside or get inside the EC2 instance, or which allowed our hacker to actually make use of the EC2 instance. So the lesson there is that if you are going ahead and actually using any open source software, then make sure that you are configuring it correctly, right? Very simple. Not saying that you should not use an open source software. Please go ahead and use whatever you like, but then you should know that how to go ahead and configure it correctly. Or why not go ahead and use something which is a more managed service, like something like AWS WAF, right? Which is AWS's WAF offering. Now, the name is slightly tricky. I don't like its name that much because it is just called WAF, and WAF is a more of a generic product category, right? Anyway, so you can go ahead and use AWS WAF, and if you do that, then it comes with a lot of best practices inbuilt, and it improves your overall security posture, really, because that is standing as the outermost layer for your setup. That was first thing. Just not that. The next bad thing was that they had configured or they had given this IAM role to this EC2 instance, which had way more access than required, right? Way more access than required. So this particular IAM role had access, like had full access to all the S3 buckets, which was actually not needed, right? On this particular machine, just you are running WAF. Maybe if you are using one bucket for some purpose, you should actually go ahead and write a custom role, which means an IAM role which has got custom policy which gives access only to a particular bucket. But instead of that, it is very easy. People go ahead and use inbuilt IAM policies, and because of that, access was given to all the S3 buckets, right? So that was the second thing which was done incorrectly. Of course, as soon as the person figured out that with these credentials I can actually go ahead and access all the S3 bucket, they just went ahead and accessed that particular S3 bucket and got all the data. Now, it is possible to actually go ahead and restrict it at your S3 bucket level as well. Now, this particular S3 bucket, which had all this confidential data which got leaked, of course, that S3 bucket was not designed, or I should say that particular S3 bucket was not required to be accessed from internet directly, right? So maybe there is, think about it. Let's say there is some program which is running in one of the EC2 instances, and that EC2 instance might access that S3 bucket. But there are very less chances that you want to expose your S3 bucket to the whole world, right? You don't want to expose it to the whole world if your S3 bucket has confidential data. Now, someone might say, hey, on this particular S3 bucket, I'm not making any of my files public, or I'm not enabling public access. Yes, understood. You're not doing that. But think about it this way. In your S3 bucket settings, if you enable public access, it means anyone without authentication can go ahead and actually access your bucket data, right? But the second thing is, even if you are not enabling bucket, if you are not enabling public access on your S3 bucket, but any of your users can go ahead and configure their credentials on their device, which can be totally outside of AWS, and they'll be able to access your S3 bucket. Now, there is a way to restrict that as well, right? And if you have gone through concepts like VPC endpoint and conditions in bucket policy, you would know that. So what you could do is, on this particular S3 bucket, you can go ahead and apply a bucket policy, and in that bucket policy, you can enforce conditions that, actions like writing to this S3 bucket or reading from this S3 bucket can only happen from a defined IP address range, or it can only happen from a particular VPC, or it can only happen, by using a particular VPC endpoint, right? So that is other thing which can be done. So let's say if we go ahead and on our VPC, if we set up a VPC endpoint, a gateway endpoint. All right. So what you can see here is that by introducing VPC endpoint in your VPC, you can go ahead and create a gateway endpoint, and with that, you can actually ensure that all the traffic from your EC2 instance goes to your S3 bucket via this particular VPC endpoint. right? So that is first thing, which is basically enforcing it from the VPC level. What you can do next is you can go ahead and apply a bucket policy at this particular S3 bucket level, right? All right, so you can go ahead and actually apply a bucket policy and restrict the actions like read, write, etc. on to this particular S3 bucket only via this VPC endpoint. So what would be the benefit of that? The benefit would be that, let's say, worst case, right? Let's say if we look at the same scenario, hacker got the credentials and tries to hit your S3 bucket and tries to run the sync command or tries to copy the data out from this S3 bucket to their own device. It won't work, because even though they have permissions to call S3 get object on this particular bucket, but at this bucket level you have put a condition that get object or put object would only be allowed if the request is coming via this VPC endpoint. And because when your hacker is trying to do that, it won't be coming via this VPC endpoint, that attempt to copy the data out would be blocked, right? So those are few things which you can do. Till now, all the measures which we talked about are the measures which were available at that time, right? It was just about, kind of missing on following the best practices. That's what it was. But post this, AWS actually went ahead and introduced something new. So the instance metadata service which we were talking about, they figured out that we need to improve its posture, its secure. They figured out that we need to improve its security posture. So they went ahead and released instance metadata service version 2. Now this instance metadata service version 2 brought in some additional requirements or some additional security measures, which I'll show you, and you will understand that how you can go ahead and actually improve the overall security posture in your environment by using instance metadata service v2, in short IMDSv2. Now though it has been a number of years now, but if you go ahead and still check in many of the deployments, you will find that people are still using IMDS version 1, which is not recommended anymore by AWS, right? You might have a certain dependency because you have written some code which uses version 1, but it is recommended by AWS that you take time and update your application and start using version 2 because it has got its own benefit. So I'll show you in the demo that how can you go ahead and use version 2 and what is different in in this new service. So before we get into the demo, I just want to summarize this thing briefly. You understood that what the setup was and what were the different mistakes which were done here, right? You understood that the settings at the S3 bucket level were not strict. IAM role which was given to the EC2 instance had a lot more permissions than what was required, and over and above that, the WAF software which was configured on this particular EC2 instance was not done properly, and because of that, hacker was able to do an attack, an SSRF attack, and was able to run the commands which they wanted, right? So those were the things which we understood. Now let us go ahead and take a look at a demo where we'll try to have a similar type of environment, and we will see that how does it look like without following the best practices and with best practices, so that you get an idea of this whole thing. Okay. All right. So I'm operating in one of my AWS accounts, and this is the page to launch an EC2 instance. I'm sure you know most of this stuff, so I'm not gonna tell you about each and everything here. But I just quickly want to scroll down and go to this advanced details. And when you actually go here and look at this option, so you have got metadata accessible. By default, it is enabled. If you want, you can disable it. And which metadata version do you want to use? So first of all, if you go ahead and disable it, of course, it means that you don't want to use instance metadata service at all. So you are just disabling it. There could be a disadvantage if you disable it. You need to understand, if you disable this, then your user data functionality won't work anymore. Okay, so user data functionality works because of the instance metadata service, right? It is a part of it. So well, you don't have to disable it, so keep it enabled, but you need to select the metadata version carefully. Now you have two options, v1 and v2, where it is written token optional, and v2 only, where it is written token required. In simple terms, this is the older thing, right? This is the older thing. And if you select this, it says EC2 recommends using metadata version 2 unless you explicitly require version 1. So if you go with this one, you have v1 and v2 both available, which essentially means that you can go ahead and use the older one. And the problem with older one was that from that particular EC2 instance, you can go ahead and just query it without any additional step as such, right? But if you go with the version 2, then what happens is you need to do an additional activity to first get a token for your session, right? You need to get that, and then every time you try to access the instance metadata service, you need to specify that token, and it will be in your control that when you create that token, you can specify that what would be the expiry period for that particular token. Okay, so it's like you create a token and your session is identified by that particular token. You can go ahead and have multiple sessions, there's no limit as such. And you can specify the expiry of your token. As I said, I think the maximum period or maximum duration which is supported there is 6 hours. That's the maximum thing, but you can specify it even to be 60 seconds or whatever you like. Okay, so that's the thing. And then there is also a very useful thing here called metadata response hop limit. So it is recommended that if you are using v2, right, keep this number very low. Keep this, for that matter, keep it 1, right? I will explain you the significance of this particular field just in a bit. Okay, but before that, so this is the important thing which you need to select while you are creating an EC2 instance. You can also change it later on, right, once the instance is launched, but this is the option which you need to change if you want to go with v2 version. Okay, now what I've done here is I've gone ahead and already created 2 EC2 instances just to save time. So this is I've called it v1 just to identify, because in this particular instance I have specified v1 and v2 both. So you can see here in this one I have specified v1 and v2, and that's why it says that IMDSv2 optional. So here they show the label in different way, but here we have chosen the older thing. If you go to the other one, which is v2, right, you will see that IMDSv2 required, which means it will use the newer thing, which is the version 2. Okay, so I'll show you the difference, that how does it really affect. So I hope you understood that we have got 2 EC2 instances, right? One is using the v1, one is using v2, right? That's the difference. And we will just go ahead and connect to these 2 instances quickly. Okay, so this window represents V1 and this window represents V2 EC2 instance. I also want to tell you that both of these EC2 instances are there in the public subnet of my VPC, and um, as such, you will see that in my VPC, I also have a VPC endpoint already deployed, right? So I just thought of doing it beforehand so that it saves time for you. In case you want to look at the process of creating a gateway endpoint, there is a video already on the channel and I'll link it below. You can go ahead and take a look at it. It's very easy process. So we have a gateway endpoint for S3 service already created, and we will see we'll go ahead and make use of this particular gateway endpoint, with our S3 bucket as well. As I was talking to you earlier, we'll go ahead and make use of this particular thing. Okay, so first of all, let's try to look at this one. We will go ahead and do a curl. So from the V1 machine, I'm able to hit this URL and it gives me the, all the details. So within here, I can go ahead and let's say I can go ahead and look at identity credentials. So you see here in the reply it gives EC2. So that means we have to go and further get inside this. And there is info. Okay, so it gives me some details that, okay, this is the account ID, some last updated date, etc. So please understand, like in identity credentials, this is more about the identity of this EC2 instance as such, right? It is not about any role which it has assumed. Now, if you want to find out about the role, you need to get inside IAM, right? So you can see here there's an IAM folder as well. So get inside IAM, and what do you get? Actually nothing. Why? Because if you go ahead and look at this, currently I have not allocated any IAM role to this EC2 instance, right? It is empty. Right, same is the case for the other one as well. But before we just go and allocate an IAM role, I just want to show you, if I try to execute the same command here, you can see that we get this error that it's unauthorized, right? So what's the method? How will you go ahead and actually use or actually go ahead and first get a token? So the method for that is you need to actually run a put command here, right? So if you see, this is a simple command. What we are doing is we are actually issuing a put command to this particular URL, which is the same instance metadata URL /latest/API/token, and we are passing TTL value, TTL value for this token, that for how long this token should be valid. So it is in seconds, 21,600. I think it comes to 6 hours, right? So the token got generated and it is also stored in this particular variable. If you want, we can go ahead and look at it. Let's echo that. So this is the token, right? So next thing is, when you want to go ahead and actually execute any of the or if you want to go ahead and actually query or access instance metadata service, you need to specify this token every time. So we'll go ahead and execute this. Now you can see it works. And what we are doing is we are actually passing this token. You can see AWS EC2 metadata. As part of the header, we are passing this token. We are making use of this variable here. And after that, when we go ahead and actually try to access this URL, it works, right? Without this token, it won't work. For example, if I try to go ahead and still run the previous thing, like if I try to do a curl directly to this, it won't work, right? But if I go ahead and do it with the token, it works, right? So I can go ahead and of course access anything further within this. So for example, if I go ahead and write ami-id, yes, it will work, right? So you can see ami-id was written. So it is all clear till this point. What we'll do next is we'll go ahead and actually just allocate an IAM role to this particular to both of these instances. So I've created an IAM role here already, which I'll just show you. And I'm actually going ahead and just allocating that particular IAM role to these EC2 instances. All right. So it is allocated good. And we should be able to see that here as well. If you look at this particular IAM role, right, it's a very simple IAM role, and this IAM role is created with a purpose, and the purpose is to allow access to a particular S3 bucket. So that's why I've gone ahead and I've written an IAM policy as well. In this IAM policy, the IAM policy is called S3 read policy. Well, it is just intentional for this particular bucket. So what I've done here is I'm just allowing S3 put object and get object, basically ability to write some object to this S3 bucket and also to download any object from this S3 bucket. Which S3 bucket? This particular one, 1002 secrets bucket. So that's the name of the bucket which I've created in my account, and this particular policy just allows these two actions. Okay, so only this policy is associated with this IAM role at this point. Okay, now let's get back to this first instance, and you remember the output from the last command which we had executed. There was nothing inside IAM. Let's go ahead and run this again. Now you can see this info thing started coming, right? So let's go ahead and access that. And when you actually see carefully, there are two things, info and security credentials, right? So when I access info, right here, I access info, metadata /IAM/info, I am able to get that instance profile ID and instance profile ARN. So what happens is, when you allocate an IAM role to your EC2 instance, conceptually this instance profile gets created. If you look at instance profile ARN, you'll be able to understand very easily that this instance profile ARN actually is referring to the IAM role which we have allocated, right? So you understand that, right? So what we do next is we will go ahead and actually will try to get inside the other folder, which is security credentials. And when we hit that, you can see it then gives the name of the IAM role which we have allocated. So I'll go ahead and try to write that as well. You have to see here, this is where the result is coming. Okay, so I'll go ahead and press enter, and this is where the credentials for this IAM role are out. Okay, so look at this. You have got an access key ID, you have got a secret access key, and you have a token as well. And what is the expiration or like expiry period for this particular token, that is also mentioned here. Okay, so the point is that as you go ahead and run AWS configure on your CLI, right, and then you specify your access key ID and secret access key, which actually belongs to your IAM user. In the same way, you can go ahead and configure access key ID, secret access key, and the session token if you want to use a temporary set of credentials, then you can go ahead and do that, right? So basically at this point, if let's say the hacker uh, would have executed this particular command on this machine, then at this point the hacker is able to get these credentials. All they have to do next is they just need to go ahead and configure these credentials on their laptop, and they'll be able to access the S3 bucket. Now 1 minute, in this case, the IAM role which I have created, I have given access only to a particular S3 bucket at this point, right? Whereas the original case which we were discussing, or what happened at Capital One, was that the IAM role had a lot more permission. So just to kind of simulate that, let's go ahead and give S3 full access to this particular IAM role. Okay. All right, so now you can see this particular role has got S3 full access policy and also the other policy which I had given. Okay, fine. So essentially now if I go ahead and configure these credentials onto my laptop, right, I should be able to access all the S3 buckets easily, isn't it? Let's go ahead and try to do that. So when you run AWS configure, it will ask you about these things, of course. So I'll go ahead and specify. US East 1 is okay, JSON is okay. But here it's not asking me to specify the session token. And if I go ahead and try to run, let's say AWS S3 LS at this point, it won't work because these are not long-term credentials. For these credentials to work, the session token should also be specified. So how can you go ahead and do that? Easy. Here is the credentials file, which you can find out on your laptop easily, right? If you have configured CLI, you know that. So it will be there in this .aws folder, right? So I've opened that credentials file, and what I will do here is I will go ahead and specify the session token here as well, right? So let us go ahead and copy it. All right, saved. So let's minimize this and let's come back here, and we will try to run the same AWS S3 LS again, and you can see that it is actually listing down all my S3 buckets at this point, right? So I'll go ahead and blur that, right? But anyway, so it is listing down all the different S3 buckets which are there in my account. And because this particular IAM role has all the permissions, so I can go ahead and easily copy the content from any of these buckets to my laptop, right? So for example, if I just try to do okay, so I'm gonna run this command which will copy a file which is inside 1001 secrets bucket, and I'll try to copy it to my local to my laptop. Okay, it says this file doesn't exist there, right? So the reason is it's actually a JPG. Oh, okay. So it was trying to download, but looks like there is an issue with my local. So what I could do is I can Okay, I'll just get inside this folder and then I'll go ahead and run this command once again and it should work. Okay, so looks like it is working. Okay, so you can see that I'm able to list and this local.jpg just got created. Okay, so this file is available now and like I was able to download it. So the similar type of thing would have happened. Now I downloaded it from a particular bucket 1001 secrets bucket, and you know the reason as well, because I have this sort of access. Right now I want to show you that if we actually um, limit our S3 bucket, if we go ahead and protect our S3 bucket, this type of thing won't be possible. So let's look at the bucket 1002 secrets bucket. Right, for now just consider that this particular role has full access, has full S3 access. Right, so of course it should be able to go ahead and hit any S3 bucket as such. Right, now in my bucket 1002 secrets bucket, if I'm following the best practices, what I'll do is I'll go to permissions and I'll go ahead and put a bucket policy. So here I have specified a bucket policy. It's a very simple bucket policy. And what I'm writing in that bucket policy is I am denying certain actions like S3 put object, get object, delete object. These things I'm denying on this particular resource if a particular condition becomes true. What is that condition? If the AWS source VPCE is not this. What is this VPC ID? VPC endpoint ID? VPCE, if you see, this is VPC endpoint ID. You can go ahead and check this. This is the one, right? 8ECC. So that's the one which I am specifying here. So what I'm essentially saying is if these type of actions happen like put object, get object, or delete object, and the request is not coming from this VPC endpoint, then go ahead and just deny that particular action. Okay, so let's go ahead and test it. Right, in this bucket also actually I've put a simple 1.jpg file. So we'll go back to our window here, and what I'll try to do is I'll try to execute the same command, but this time with 1002. Right, and I will go ahead and try to call it local2. So let's go ahead and try to execute this. So from IAM perspective, from IAM role perspective, my user, or my IAM role, I should not say user, my IAM role for which I have configured the credentials, that IAM role has all the S3 permissions. But what I've done is at the S3 bucket level, I've gone ahead and enforced an extra condition, because of which now that S3 bucket kind of becomes inaccessible when someone tries to access that bucket from anywhere outside of that VPC, right? Unless until that request comes via that VPC endpoint, right? That request won't be honored. So that's why even after having all the S3 permissions, if I'm not able to copy the content from this particular S3 bucket. So you learned, you just now saw that how you can go ahead and improve the thing with your S3 bucket, right? So to summarize this one, what you understood was that, see, of course it would be best, it is the best thing to ensure that you are giving only the required permissions, right, in your IAM role. Many of the times people find it difficult to go ahead and write custom IAM policies, so they try to just go ahead and use the existing IAM policies in all the scenarios, and that opens up a lot of access. Basically it gives you a lot of access. All the pre-built policies will give permissions on all the resources. They do not filter on resources at all, right? So you have to understand that though there are different policies, something will allow read-only access, something will allow write access as well. So there's a difference in terms of actions allowed, but there's no difference in terms of the resources. If there is a particular policy, let's say S3 read only, right? So it will allow read access to all the S3 buckets, right? In the same way, if you go for S3 full access, then it allows all the actions on all the S3 buckets. But in your production scenario, or as such in your cloud environment, you should not go ahead and operate that way. You should write custom policy, custom IAM policy, using which you can allow access to only those resources which are required, and you should also ensure that you are allowing only the required actions, and like just you are not just going ahead and giving all the actions blindly, right? So don't do that. So that would be the best thing. And I showed you that even, let's say, like even if the best practice is not followed at this level, then you should go ahead and try to take care of it at your S3 bucket level as well. So that was the thing with the S3 bucket policy, via which you are ensuring that your S3 bucket will not be accessible, when someone is issuing the command from outside of your VPC. So you can go ahead and enable such things by putting a condition in your bucket policy. The last thing which we want to briefly discuss is this particular feature which I was telling you about, that maximum hop thing, right? So this particular thing which says metadata response hop limit. So here is the thing, right? Some of the times you will have a use case where you want to go ahead and use your EC2 instance to actually configure a firewall, or maybe you want to use your EC2 instance as a NAT instance, right? So if you go ahead and do that, that's where this becomes very important. Please understand, the first recommendation would always be that go ahead and try to use a cloud provided managed service. Try to use NAT gateway, try to use AWS provided firewall. But let's say if you have to go ahead and use your EC2 instance for these things, then go ahead and make sure that you specify the value for this thing as 1, right? So what happens with this is that when you go ahead and actually try to get the token first time with the IMDS version 2, the put response, the response of that put which gives you the token, that response will not be able to travel outside of that particular machine. I mean, there is a detailed explanation for that. If you want, I will link an article which you can go ahead and read. But the thing is that if you go ahead and set the TTL value to 1, it would mean that the request, that the request to get the token and then would be accessible only from that EC2 instance level. Even when your EC2 instance is operating as a NAT or as a firewall, the response for this particular call, or basically the token which got generated, would never be able to go out of your EC2 instance. That's what this particular thing ensures. Okay, so please make sure that you, if go ahead and look at your EC2 instances which are currently running, and try to find out that whether you are using V2 or you are still using V1. You can run commands and filter based on that particular property. I already showed you that you have this property shown here, so you can easily filter on it and get a report, and then plan to transition to the V2 one, right? Of course, when you plan to transition, there are all the compatibilities which you need to look at. If you are making use of this IMDSv2 as part of your application, you need to go ahead and probably modify your code a bit, right? So let us summarize this. One lesson which we understood here is that we need to go ahead and create IAM roles with custom IAM policies, right? And in those custom IAM policies, we should allow only the required actions which are there for a particular program or for a particular application, right? We should only specify the required actions and the required resources. You should try to avoid putting stars as much as possible in your IAM policies. And we saw that how in this particular scenario, they had created an IAM role which had kind of full access to all the S3 buckets. You should not do that. You can go ahead and limit the access of your S3 buckets so that they are accessible only via VPC endpoints, right? So look at the use case, and if your S3 bucket, like if you have that type of data which is quite confidential, then first thing, keep it in a separate S3 bucket, and then go ahead and put bucket policy so that it is accessible only from your VPC endpoint. You can do that via bucket policies. Use IMDSv2 on your EC2 instances. If you have not enabled it yet, go ahead and modify your instances, of course with careful consideration, but go ahead and modify it so that you disable or you stop using version 1, right? And of course, if you are using your EC2 instance for NATing or for fire or for NATing or for firewall, etc., go ahead and specify the TTL value to 1, right? And as much as possible, please try to keep an AWS provided managed service at the outermost layer of your architecture, right? It could be AWS WAF, it could be ALB, it could be CloudFront, but the outermost layer should be an AWS provided service. That will really improve the security posture for you. So I hope you learned something from this particular video, and I hope you will be able to relate these concepts and how you can go ahead and actually use it in the real world. If you have any questions or doubts or comments, feel free to write it down, and I'll try my best to reply you. If you want to learn more about AWS security topics, please check our AWS security playlist, which you will find in the video description. We'll meet again in the next video. Till then, take care. Bye-bye.